All right. Good afternoon, guys. So yesterday we have seen this network components. That is what is router, switch, and then hub. We have seen the differences, correct? And then what else we have seen? LAN man network. We have seen what is broadcast domain, collision domain. Those things we have seen. Cables we have seen. So today we'll learn what is IP address. Okay. So in depth we'll learn why it is 32-bit. Okay. What is the range of IP addresses? Those things we'll learn today. Okay. I find you new. First class? This is your first class. Any new students from online?
It's me, sir.
It's you. Okay. So you guys send me. I need your details by end of the class. I'll get it. Okay. All right. So today we are going to learn the IP addresses. So we have logical address and physical address. This is not hard coded. These are hard coded in your PC. Okay. These are not fixed. That means it is changeable. These are fixed. And then it can be changed. It cannot be changed. Example, IP address, and that is 32-bit. Because, for example, you can say what address? MAC address. And then this is 48-bit. Okay. So we have logical address and physical address. Logical address is not hard coded. It is not fixed. That means every time when you get the IP, it is changeable. You can change the IP. Whereas your physical address, you cannot change it. That is your MAC address. It is fixed in your PCs. Okay. And under this logical address, first of all, what is IP address, guys? Tell me what is IP address? What is IP address? Whatever you know.
It is unique address concerning for computer providing.
Okay. Anyone else?
Kind of domain name.
Kind of domain name of a website? No.
It is a unique code.
Yeah, online someone was answering.
It is a unique code.
Is used to identify a host in a network.
Okay.
It is unique identification of the host.
Okay. So it is a unique logical. That word is important. Logical address that is used to identify the host in a network. Okay, and we have two versions, that is IPv4 and IPv6. 4 and IPv6. So in your IPv4, it is what? 32-bit. Okay. And it is separated by dot. Okay. And then the value is in decimal format. Decimal format. Okay. The address. And it has 4 octet. It has 4 octet, and 1 octet is equal to 8 bits. This is a IPv4. For IPv6, it is 128 bit, and then it is separated by colon. It is separated by colon, and the value is in hexadecimal. Okay. And then here we have 8 hextels. We say it as hextels. Hextels. Okay. And then 1 hextel is equal to 1 hextet is equal to 16 bits. 16 bits. Write it down. These are your basics of your IP addresses. So why we need an address? We need a unique name to call someone, correct? So here we have a name. Okay. So one person cannot have a same name. Correct. He can have, say, for example, if there is a person called Hari, there might be another Hari, but his father name can be, for both of them also can be same name, but still they will have a unique name. For example, Aadhaar number. He can't have a different, I mean, same Aadhaar number, right? He will have a different Aadhaar number. Likewise, it is a unique number within a network. Within a network, that number should be unique. Then that is logical address. Okay, so within a network, there can't be two same IP addresses. Okay, you can have a same IP address, but that should be in different network. Within a same network, that is not possible. Okay, now,
Sir, these both are logical address, right?
yes, they are logical address.
IP4
Only
and
your
IP6.
MAC address is the physical address. Other than that, every address is your broadcast address, network address, IPv4 address, IPv6 address, link local address. Every address is logical. Okay.
Okay.
Um, 1 pibble is equal to 2 bits. Okay. 1 nibble is 4 bits. 1 byte is equal to 8 bits. Very good. Write it down. 1 kilobyte is equal to 1024 bytes. 1 megabyte is equal to 1024 kilobytes. 1 gigabyte is equal to 1024 megabytes. Written? Okay. So now we will learn this binary. Okay. See, your IP address is, say, for example, 8.A.B.C.D. Okay, that means 0.0.0.0. Okay, so our IP address is what? 4 octets. This is 1 octet. Okay, and each octet is separated by dots in your IPv4. So 1 octet, 2, 3 and 4. 4 octets you can see, correct? So how many is 1 octet? 8 bits. So when I say 1 octet, then you have 8 zeros here. Okay. Likewise, this is the representation of your IPv4 address. So in short, you see it like this. In terms of octet, that is what? 4 octets. So 4 octet we say, or we can say 4 bytes. Both are same, because here you can see 1 byte is also 8 bits. 1 octet is also 8 bits. Okay. Technically we say octet. Okay. So 1 octet is how many bits? 8 bits. So here you can see 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this is the representation of your IPv4 address. Now I'm going to teach you the how to convert binary to hexadecimal, decimal to hexadecimal, and binary. So now I'm going to show only 4 bits. This is 4 bits, correct? 4 bits. I'll teach you only the 4, and then we will go to 8, and then we'll see the range of IP addresses. Okay. See, your IP address is always starts from 0. 0 always have a value in your IPv4 address. Never skip 0. People always make mistakes in zeros. They will skip the 0, they'll start from 1. No, you always start from 0. Thumb rule in your IPv4 address. What is the thumb rule? Always start from 0. When I say 100, then that is 0 to 99. When I say 50, that is 0 to 49. When I say 17, 0 to 16. Okay, in your IPv4 address. And IPv4 address always starts from right to left. Okay, not left to right. You should always go from right to left. That is also the another thumb rule. Go from right to left. Another one is always never forget the 0. Always add the 0. Okay. So here I'm having zeros, 4 zeros. Correct. That means here it is 0 to the power of 2 to the power of 0. The value of this bit is 2 to the power of 0. Okay. And value of this bit is 2 to the power of 1. Okay. And then here 2 to the power of 2.
Cube. 2 raised to 3.
Okay. So this is the value of each bit. So I'm teaching only the first 4 bits. So first bit is 0. So that's why 2 to the power of 0. I'm starting with 0. And then 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3. Okay. So what is the value of 2 to the power of 0?
1.
1. 2 to the power of 3 is 8. This is 4.
4.
2 and 1. Okay. So if I say value of this fourth bit, then you have to say it as 8. When I say value of this bit, then that is 4. Why 4? Because I'm starting it from right to left, and it will start from 0. So 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. So that's why it is 4. Understand the logic and then calculate. Simply don't say, okay, if it's third bit, 4. No, not like that. You have to understand, since it is starting from 0, so that's why 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. Okay. So now we will do the decimal, binary, and hexadecimal. Okay. So first I'll start with 1. Okay. So here you see any value of 1. Yes, we have value of 1. That is what, which octet, which bit? First bit. So I'm going to turn off the other bits. Okay. I'm going to turn off other bits, and I'm going to turn on only the 1 bit. Okay. So that's why it is 1. So here it is value of this first bit is 1. I've turned it on. Okay. Next 2.
0, 0, 1, 0.
Yeah, wait. So here we have 2, right? So value of 2 is this bit value is 2. So I'm going to turn off the other 2 bits and turn on only the 2 bit, and the other bit I'm going to turn it off. Okay. And then we are having 3. So we don't have any 3 here. So I'm going to add 2 plus 1. So when I add 2 plus 1, then it will become 3. Correct? So I'm going to turn off the 8 and 4th bit, that is 3rd and 4th bit, and I'm going to turn on the other 2 bits. Okay. So likewise 4, but we have 4 directly. So I'm going to turn on only the 4th bit, that is this bit, 3rd bit of your address, and other bits I'm going to turn off.
Sir, I didn't understood third one, sir. Please
Third
explain.
one. Okay. See, third one, the value is 3. We don't have 3 here. Do we have 3? No. So I have to add 2 plus 1.
Okay.
So that's why I turned on this bit and this bit so that the value has become 3.
Okay. Okay.
Here you can see.
Okay, understand. Yes.
See again, who asked me this question?
Raghavendra.
Raghavendra, see, here I'm having 5.
Yes.
Okay, 5. Is there any 5?
No, sir. 5 is not there.
5 is not there. Then I have to add 4 plus 1, correct?
Welcome.
So I will turn on this bit and this bit. Other
This
two
and this bit. 0. Oh, yes.
correct. 0, 1, 0, 1.
Yes.
Any doubt on this? See, this is very basic.
No.
No, not you. In general, I'm asking. If any doubt, clear it right now. Because if you don't understand this, there is no point of explaining you the next topic. Okay? So what is the 6? Tell me, guys. We don't have 6. So it is 0, 1, 1, 0. Then we have 7. 0, 1, 1, 1. After add 4 plus 2 plus 1. We have 8. 1, 0, 0. And then 9 we have. There is no 9. So 8 plus 1 I'm going to say 1. Correct. 10. 8 plus 2, that is 1. 0, 1, 0. Then we have 11. 8, 0, 1, 1. 12. 8 plus 4, so 1, 1, 0, 0. And then 13. 1, 1, 0, 1. Then we have 14. 1, 1, 0. Correct. 15. 1, 1, 1, 1. Now the bit is exhausted. So we'll stop here. Now come to the hexadecimal. So value of 1 is 1. 2 is 2. 3. 4. And then we have this A, B, C, D. That is 10 will become as A. Okay. And 11 will become B. B. C. We have D. E. F. Okay. So this is the, yeah.
Can you tell me the hexadecimal?
See, when,
how you have taken one?
See, hexadecimal is in which IPv? IPv6,
Okay.
we have hexadecimal. In IPv4, we don't have. In IPv6, the address will be like this. Say, for example, 002A. Okay. So IPv6 address will be like this.
Okay, sir. This I understood. 1, 2, 3. Why you have taken that?
1, 2, 3. Where 1, 2, 3?
Yeah. From starting hexadecimal 1, 2, 3, 4, 5.
Value of 1 to 9 is 9 only. That is the value of hexadecimal.
Oh.
Okay.
Okay.
From 10 it will start to change. So I will explain you.
Then alphabets will come.
Correct. So this is your one hextet of your IPv6. So one hextet is how many bits? I've given you the note.
16.
16 bits. So this is 4 bit. this is 4-bit and this is 4-bit. Okay, so the 0 will be like 0, 0, 0, 0. Are they 0, 0, 0?
0, 0, 0.
And then this will become 0, 0, 1, 0. And A is what? 10. So 8, 0, 2, 0. So this is how your IP
Okay.
address will be in your IPv6.
Okay, sir. Understood. Thank you.
Okay. So that's why we have this hexadecimal. Your IPv6 is in hexadecimal, not in IPv4. Okay.
Okay, sir.
All right. Write it down this quickly. Today I'll give you the drive access to everyone. Written, guys? Everyone? Okay. So now we have seen this first 4 bits, right? That is 0, 0, 0, 0, 0, 0, 0. In one octet, that means in one octet, I've shown you only the first 4 bits. Now we'll see this 4 bits. That is what? Again, this will become, wait. This is 2 to the power of 5. 2 to the power of 6. And this is 2 to the power of 7, and this is 2 to the power of 1, 2, 3. This is 4. Sorry. This is 5. This is 2 to the power of 6. 2 to the power of 7. Okay. The first 4 bit is 2 to the power of 3. Next 2 to the power of 4, 2 to the power of 5, and 2 to the power of 6. Okay. So here how the values will be here. 2 to the power of 7 is 128. 2 to the power of 6 is 64, 32, and 16. So what is the value? It is 0 to 255. Okay, when you add everything, you will get the value of 255. So a complete octet will be set, I mean, it will be exhausted when it is 255. Okay, see, here we have this one, right? 8 plus 4 plus 2 plus 1. What is the value? 15. Okay, and if we add everything here, then the value will become 255. Okay, so if I say, for example, 100, then how the value will be? So you have to add till it gets 100. So 64 plus 32 is what? 96. So 128, I will turn it off. Okay, 64 and 32, I will turn it on. If I add 16, it will go beyond that. So I will turn it off again. If I add 8, again, it will go beyond, so I will turn it off. So if I add 4, then it is 100. So I will turn on 4. So 2 and 1, I will turn it off. So this is your binary to decimal and decimal to binary. Okay, so we don't have 256. We don't have 256. So it is 0 to 255 we say. We say it as 0 to 255. So one octet value is what? 255. Next octet value is 255. So if it's completely 0, 0, 0, 0 like this, if it's like this, then the value is 0 dot 0 dot 0 dot 0. If everything is 0, it is like this. What if everything is like this? 1, 2, 3, 4, 5, 6, 7, 8 dot. If it's like this, every bit is on. So it will become 255 dot 255 dot 255 dot 255. So your range will start from 0 dot 0 dot 0 dot 0 to 255 dot 255 dot 255 dot 255. Okay, this is the range of IP address. If you ask me why it is 255, now you know the value. Because each bit has a value. That is starting from 2 to the power of 0, 2 to the power of 1, 2, 3, 4, 5, 6 until 7. So when you add every bit in one octet, then the value is 255. So that's why the maximum range is 255 and the minimum is 0. Okay, any doubt on this? No, right? Online guys, any doubt?
No, sir, clear.
Okay. Quickly write down these things. And also this table you can write down. Vishal, understood?
Hello, sir.
Yeah.
Sir, after that 2 raised to 4, we have to write no. That's right side.
What you
2,
have?
2 cube, 2 square like that.
That you have already given, right? You have written here already, right?
Okay. For denoting every number, we can write like this and represent in binary.
Yeah. See, if I say this bit, then what is the value of this bit? 2 to the power of
2
0,
raised
1, 2,
to
3, 4.
2 raised to 4.
4. Because 0, 1, 2, 3, and 4. So 2 to the power of 4 is 16. So value of this bit is 16.
16.
Likewise.
We have for this we have to count from left to right or
Obviously, right to left. That's what
right
I
to
told
left.
you, right? Yeah. Never come from left to right. Always right to left.
Right to left.
Yeah.
Okay.
You can write down the value of 100 also here. Like this, you can write down so that you'll understand. Thank you. Actually, I have two new students. Karuma.
Today,
Online guys, whose first class is it today? Like, I mean, if you're offline, you're already given the details, that's fine. Like, this is my first class, like both online and offline. Is there anyone like that? Ravi Verma.
Ravi Verma is there, right?
Okay, so
Physical.
Satish. I think only one offline student.
What's your name? Ahmad. Okay.
Okay, I will get this detail.
Okay. அப்புறம் அதுல விஷால்னு சொல்லிட்டு
Always. All right. So now you'll learn the range. So how it's going to be set. That means 0. Correct? So this is your starting range of your IP address. 0.0.0.0 means every bit is off. Okay. So first you always come from right to left. So it is 0. So it is 0.0.0.1. Okay. When I say 1, that is what? 0.0.0.0.0.0.1. So first 7 bits are turned off and then the last bit is turned on. That is 1. Because 1 octet is 8 bits. Okay. So it will start from 0.0.0.1 to 0.0.0.2. Correct? Then correct. It will go till 0.0.0.255. Okay. Because it will go from 16, 17, 18, 19, 20 until the maximum range is 255. After 255, there is nothing because every bit is turned on. Correct. So now what we are going to do, we are going to move to the next bit. Before that, you can see like this. See, if I'm saying 2.2.2.0, okay, it will go from 2.2.2.1. 4. It will go till 2.2.2.255. Likewise, it will go. Okay. Now come to this 0. So now what happened? This fourth octet is exhausted now because everybody is turned on. We can't use this. Now what I'm going to do, 0.0. Now which is the next bit? This bit. So I'm going to turn on this bit. 1 dot. Again you start from 0. Okay. You don't say 255. Again you start from 0. So how it will go? 0.0.1.1. 0.0.1.2. 0.0.1.3. It will go till 0.0.1.255.
255.
Okay, now what happened? The fourth bit got exhausted. Fourth octet got exhausted. So now what will happen? 0.0.2.0 again. You okay, and then 0.0.2.1 it will go 1, sorry, 2, 2.3. Correct, and it will go till 0.0.2.255. Okay, likewise, how much it will go? 0. It will go till 0.0. Until this third octet gets fulfilled. Dot 0. Then it will go till 0.0.255.1. 3. It will go till 0.0.255.255. Now what happened? The third octet is also exhausted and fourth octet is also exhausted. Now you come to the second octet so that it will become 0.0. Sorry, 0.1. Again 0.0. Okay, now what will happen? 0.1. First, fourth octet gets fulfilled, exhausted. Then come to third octet, then go to second octet. Okay. So 0.1.0.2. Likewise, it will go till 0.1.0.255. Correct. Now what it will change to 0.1.1.0. Very good. 0.1.1.1. Correct. And it will go till 0.1.1.255. Now what will happen? The fourth octet is exhausted, but the third octet is still in place. So 0.1.2.0. Okay. And it is 0.1.2.1. And it'll go till 0.1.2.255. Okay. Until where it will go? Till it is the third octet gets fulfilled. That means 0.1.255.0. Correct. So 0.1.255.1. And it will go till 0.1.255.255. Now the third octet is exhausted. Fourth octet is also exhausted. You will go to second octet, but it is still one only. You can go till 255. So it will be 0.2 dot again 0.0. Likewise, you keep on go till the third octet gets completely 255. I mean 1.0.255.255.255. And then again, what will happen? 1.0.0.0 will come. Again, the fourth bit will change. Third bit will change. Fourth bit will change. Likewise, when it will get exhausted, 255.255.255.255. That is completely exhausted. Okay. Any doubt on this? If you have doubt, don't hesitate. Ask me. I'll explain again. Which bit? Which part?
Start.
See, here you have 0.0.0.0. 0.0. I'm changing the last bit. And then after 1, 2 I'm changing. 3 I'm changing. 4 I'm changing. Then I'm going till 255. Why I'm going till 255? No, I've said 0.0.0.255. Why I'm not going to 256? Answer. Answer.
Range is 255.
Exactly. The range is 255. So that's why I'm going till 255. Now this is exhausted. I'm going to the next octet. 0.0.1.0. It is going till 1.0. Then the fourth octet comes into picture. 1.1, 1.2, 1.3 till 1.255. Now this is exhausted, but the third is still in place. So that's why I'm changing it to 2. 2.1, 2.2, 2.3 and 2.255. Likewise, it will go till 3.0, 4.0 till 255.0. Okay. And then 255.1, 2, 3 till 255.255. Now this 2 bits is exhausted.
Yes.
2 octets are exhausted. Now I'm going to the third octet. Here. So 1.0.0 again, you change the, once you change the octet, the other octets will become 0. Okay. And then 1.0.1. Because fourth octet haven't been exhausted yet. So I'm going with 0.1. Then 0.2 till 255. Now 255 is exhausted, but still this bit is in place. So I'm changing it to 1. So likewise, I'm keep on changing the third bit. Where the third bit will exhausted? At 255.0. I'm going till 255.255. Now, these two octets are exhausted, but this is still in place. So I'm changing to 2.0.0. Again, it'll go from, how it will change? 0.2.0.1, 0.2.0.2. Likewise, it will go till, okay. And then what will happen? 0.2.1.0. 0.2.1.1. And it will go till 0.2.1.255. Again, it will change to 0.2.2.0. Correct. And it will go till 0.2.255.255. Sorry, 255.0. Where it will get exhausted at 2.255.255 it will get exhausted. Then again 3.0 will come. Again 4.0. So where it will completely get exhausted means here. That is 0.255.255.255. Here it will completely get exhausted. Then it will become 1.0.0.0. Okay. Likewise, it will keep on changing the octet. Okay. All right. Write down these things. Write down. These are very basics of networking. If you are going to assign an IP address, you should know what is the range, how it is changing, everything. Someone reduce the temperature. Set it at 20 or something. It's not working.
Sir, in this after 0.0.0.55, no.
Yes,
After that 0.1.0 will.
correct. 1.0 will come.
That means it will change. The 255 will become 0 and then next bit will increase
Correct. Yes.
like that.
Yes. So if possible, I'll take you to the lab tomorrow or day after tomorrow. Okay, I'll show you simply what are the routers, what is switch, what are the cables. Simply, I'll show you. And next week again, we'll go to lab and we'll take the access of routers. Okay, right now I can't show you the access because that topic has not yet came. Okay. Written. Okay. Every day after class, try to go and see the recording once again. Because in class, you will feel like, okay, I understood everything. Okay, but when you go home after a sleep, you'll forget.
Sir, when it reaches 255, then it get exhausted and then it becomes 0.
Correct. When you go to other octet, this octet will become 0. Written? Yes. Everyone? Anyone still writing? Just write on this and we'll go to next topic. Did you miss yesterday's class? You missed. You didn't come, right? Or online you were doing. Where is your friend?
This option.
Is he doing online?
Yes.
Online class.
Online.
Oh, he messaged me. Okay, written. All right. So now you know the range, correct? So I will ask you some questions. You can answer. What is the next address?
11.44.116. So
0. Correct. Because 115 is the third octet, the fourth octet is exhausted, so I'm changing it to other octet. So now 116 it will change. That is 111.115.115.116. Correct. Now 250. That is
77.78.54.55. 54.55.
after this address, what it will become? 77 dot 77.78.0.
55.0.
Okay, where this octet will get exhausted means 77.78.255.255. Here it will get exhausted. Next it will become 79.0.0. Okay. So likewise, it will keep on changing. Okay. You want to write down this also, or it's okay? It's okay. Now you understood, right? Okay. Not required. Now come to the PPT. So here we have type of addresses, that is IPv4, and it is dot separated by dot, and it is in decimal notation. That means numbers. And example is 192.168.10.1. It means what? The next IP is what? 10.2, 10.3, till it will go to 10.255, and then it will become 11.0. Now you know. Okay. So IPv6 is 128 bit. Okay, and this is in hexadecimal format. Your IPv6 is your last. I will take it in the last class. After your routing, after your switching, after like translations and few classes. So one class you have for IPv6, where I'll teach you how to shorten the IPv6 address, what is IPv6 address, what are the different types of IPv6 address, and I'll make one practicals for you. I will do one routing in your IPv6 also. Last before class. Okay. And then we have MAC address, that is also is in hexadecimal format. So what is F here? F means what is the decimal value of 50? Very good. C means 12. A is 10, 11 is B, 12 is C. Okay. So IP address is a unique address that identifies a device on the internet, okay, or a local network. And then IP stands for Internet Protocol. Okay. So it is separated by dots. I mean numbers that are separated by dots. 32-bit, 4 octet. Each octet is 8-bit. Each number is a set can range from 0 to 255. And what is the range? It is 0 to 0.0.0 to 255, 255, 255.255. And total number of IP address in IPv4 are 2 to the power of 32. Because 32 bits, so 2 to the power of 32. That is somewhere around 4.2 billion IP addresses. Okay. And decimal format is like this. And binary format is this. Okay. Clear? Now I understood, like all 10 points are clear now. Correct about IPv4. So these are the binary to decimal conversion. We have already seen this. Now quickly write down these things. This is the classes of your IPv4 address. Write down, I will explain you. I will explain. Written? Okay. So we have 5 classes: class A, B, C, D, and E. So where we're using this class A is we are using in country level ISP side. Okay, country level ISP we are using this class A, and class B we are using in state level ISP. Okay, and class C is for our use, that is VPN customers. Customers we are using this. Okay, so these are the 3 addresses that is used for assigning. Assigning purpose we are using only these 3, class A to C. IP assignment is IP assignment. Okay, only class A, B, and C we can use it. Class D and E we cannot use because class D is used for multicast. Multicast. Okay, and class E is used for research and experimental purpose. Okay. Written. Now come to this PPT. I will tell you. So here 0.0.0 is not used anywhere. So you cannot assign anything that starts from 0. That's why your range always starts from 1.0.0.0. So 0.0.0 you can't assign anywhere. That's why 0.0.0 is not used anywhere. And here you can see 127.0.0.0 is a loopback address. Here you can see there is no 127. After 126, directly we went to 128. So 127 where we are using means in your NIC card to check the connectivity. We are using this 127. So that cannot be assigned for a system. So if I have to check my physical IPs, my IP address is not able to reach, or for example, it is corrupted or anything else for that matter. So how will I check the connectivity for my laptop? I need to check the connectivity, right? So I will ping to 127.0.0. Any number. Then I'll come to know, okay, there is a connectivity. See, I'll show you. So here I'm saying ping 127.0.0.10. See, I'm able to ping. I'm getting reply. I will say ping 1. I'll get reply. So this 127 network is what? For what? To check the connectivity. So we say it as loopback. It is not a physical IP, it's like a virtual IP. It is used to check the connectivities. Okay. So that's why you don't have 127, and class A, B, C are used for assignment purpose. That means I can assign this IP somewhere. Whereas your class D and E, you cannot, because that is used for multicast. What does multicast mean? See, in your future routing classes, you will come to know. But here I'll explain in small brief. So, for example, if I have a router like this, Okay, I have 5 routers there, 5 routers at the bottom. So they are connected like this. Okay, so these 5 routers I'm going to assign RIP version protocol, that is routing information protocol. And these 5 routers I'm going to assign EIGRP, enhanced interior gateway routing protocol. So likewise, I'm going to do it. So these 1, 2, 3, 4, 5 routers up the top right, they will use multicast address 224.0.0.9. That is fixed for your RIP version protocol. Okay. Likewise, your EIGRP will use 224.0.0.10. That means within these 5 routers, they will communicate through this address. The other routers will not come to know. What is multicast? One to many, one to a specific group. So they will communicate to only these 5 routers at the bottom through this address. And likewise, these upstream routers will use 0.9. So likewise, these multicast addresses are fixed. That's why you can't assign it to end users or anywhere. That is not used for assignment purpose. This is already used in your protocols. Okay, and these other class E is for research, means like ISRO, your army, your military, they will use those addresses. That is completely not for us. Okay. All right.
Sir, this we learned no multicasting. That is same as this.
Same as what?
This we learned multicasting is same as this class D is used for.
No, see, those addresses are given for individual protocols. For example, HSRP is using 224.0.0.2 and 224.0.0.102. So likewise, each protocol will have a different address. Like EAGRP is using 224.0.0.5 and 224.0.0.6. So you
Yes.
can't use it for assignment purpose. Those are for protocols, for multicast purpose. Okay.
But in multicast, we learned like one center sending to particular group of
Yeah, that's what I said.
hosts
See,
like that.
the upstream routers will use 0.9 and they will communicate through only 0.9.
Hmm. Okay, downstream another router protocol RIP will use another thing.
No, if it's RIP, everyone will use 0.9. If it's EIGRP, everyone will use 0.10.
Yes, yes. But
Hmm.
above and below different, I'm saying, meaning
Different?
different set of IP addresses
Different set of IP addresses.
like that. You told no 224.0.0.9.
Yeah. See, it
Uh,
doesn't mean that they will not communicate. They
hmm.
can communicate. That you will learn in your CCNP.
Okay.
Okay. So those upstream routers will not share the details to downstream routers. Likewise, the
Yes, yes.
downstream will not share it to up. But in your CCNP, you'll learn how they are going to communicate. Because
Oh,
everybody in your real time is not using the same same protocols. They will use different protocols.
yes,
Okay. All right.
yes,
Is it clear?
yes.
Okay. Your doubt. Mhm.
Solely for casting they use the
Exactly. See, what happens is all the 5 routers at top, they will have individual IP addresses. IP address is totally different. We have to assign the IP addresses for each and every router that is on every interface. So upstream 5 routers, 2 interface, so 10 IPs there. Likewise, downstream 5 routers, 10 IPs there. So the IP is different. Okay, IP is for each and every interface I'm giving. So this 5 routers at the top, they will share their information to other 4 because they are all in same protocol. Likewise, the downstream, all 5 will share their information to each other because they are in different protocol. Then they will share it to them also. If everybody are in the same, they will communicate to each and everyone. Okay, if they are in different protocols, then only to that particular IP they will communicate so that the other will not know. Okay, that is your multicast. So EHRP is using 0.10 so that what will happen? He is not going to share it to others because only these 5 routers will understand 0.10. They will not understand what is 0.10 because we have not configured EHRP. And upstream router, they understand RIP version because I configured RIP. At downstream, I did not configure RIP, so they will not understand 0.9. Okay, it is reserved. You can't use. Okay, that is completely reserved. And you can't change also. All right. So that is your class D, multicast. Now you understand multicast. A, B, C is for assignment purpose. That is country level ISP. You need many addresses. That's why we are going for class A. And class B is state level, a minimal level. And then we have class C that is used for our purposes. Okay.
Sir, you are saying like these routers in RIP and EAGRP can communicate
Yeah.
like that
Yeah. That you will learn
in
in CCNP. Don't confuse now.
CCNP, not in CCNA.
No.
Okay.
Okay. Your RIP version and EAGRP is not even in the syllabus of CCNA. Forget that.
Okay.
Okay. In syllabus itself, in CCNA syllabus itself, it's not there. But I will take one class, extra class, where I'll teach
That
you RIP version 1, RIP version 2, and also EAGRP. One class you
uh,
can take and you can completely learn that. Basics.
routing protocols, right?
Correct. That is not there in your CCNA itself. All right. Before that, mm, write down this range. Very, very important. written. So what is this private IP range? So these are IP that are non-routable, and it is used to hide the internal identity from the outside world. So this is used for our purpose, for private purpose. Like if you are having a modem, Wi-Fi modem at home, you will connect to a private address only. Public addresses are used in your WAN network, wide area network. That means outside your router, they will be, your ISPs will be having the public network. Okay, so your ISP will not know, or your other router, your server will not know your own identity. It will be translated to public only. And these private IP is not in the routing table of your ISP sites. They will have only the public IPs. Okay, private IP is for what? Completely to hide the internal identity. See, what if private IP is able to routable in WAN network? Then every device they will come to know, right? That means hackers will try to get into there only. See, this is my router. I'm connected to a switch. Here I have a Wi-Fi modem, and under this Wi-Fi modem, there are multiple mobile phones, PCs are connected. Okay, and here is your ISP, Internet Service Provider, and you're accessing internet. Okay, so your packet will go like this. This is your LAN network, that is private IP. Okay, this is your WAN network. Here is your public IP. Okay, see, if this private is able to view here, then your hackers will try to get in here, and they will get all the datas. So that's why we are not going to show our private IP in the outside world. Okay, that's why it is non-routable, and it is used to hide the internal identity. This is the private IP range. And what is the range? 10.0.02, 255.255.255, 172.16.2.31, 192.168.2, 192.168.255.255. This is class A range, class B range, and class C range. Okay. Many interviews, they will ask you what is the private IP range. Simply to ask you what is private IP, does he know anything? They will check. Okay. Next, we'll learn what is subnet mask. So it identifies the number of bit belongs to network, number of bit, or I say number of octet network bit number of belongs to bit. What is network bit? It tells you to which network the machine belongs. Host bit. It is the actual machine in the network. Write down these things, I'll explain you. Written? Okay. So what is subnet mask? Subnet mask means it identifies number of octet belongs to network bit and number of octet belongs to host bit. Okay, this will come. But before that, what is network bit? Network bit, it tells you to which network a machine belongs. And host bit, it is the actual machine in the network. See, in simple, I'll make you understand. Very simple. Your WhatsApp group is your network. Correct? And you guys are inside the WhatsApp group, you are host bit. Okay, if I have to call one person, okay, for example, what is your name? Himanshu. If I have to call Himanshu, I'll simply call Himanshu. Correct? That means in my personal chat, I will text Himanshu. If I want to tell a detail to everyone, then I'll go to simply WhatsApp group and I'll say, guys, today class will start at 2:30. That means that message is for everyone. So there I'm using the network. If I use the network, I'm calling everyone. I'm calling each and everyone who belongs to this 2 to 4 p.m. batch. So that is your network bit, like your WhatsApp group number. Sorry, group. So inside that WhatsApp group, you guys are there. So you are host bit. Each and every individual. I am a host, you're a host, you're a host, you're a host. Everyone, we have an individual number, so we are host bit. Okay, this is just for understanding purpose. What is network bit and host bit? See, we have an IP address like this. 1.1.1.1. Okay, so in this, which are the bits belongs to network bit and which are the bits belong to host bit? Who will decide? Your subnet mask. Because it identifies the number of octet belongs to network bit and host bit. Correct? So here I have 1.1.1.1. Okay. So this bit only belongs to host. This other bit will belong to network. How I will understand that there is a value. Okay, that we will learn. So what is a subnet mask? It will identify you how many belongs to network and how many belongs to host. So what is a network bit? That tells you that this is like a WhatsApp group. So these all machines, this all host belong to this particular network. All these people in CCNA batch belong to CCNA batch Tamil Selvan group. Okay. And each and every individual in it is a host bit. Okay. Come to subnetting. See, here you can see a value which helps to identify network portion and host portion. Okay. And in your network bit, you can add this point. Network bits are represented by ones and host bits are represented by zeros. Add these 2 points. Network bits are represented by ones, add it in network bit. And host bits are represented by zeros, add it in host bit. Down, you can write it down. Written? Okay. You can write it down later. Now I'll just teach you. Then you can write it. Okay. See, This is your class A. That is 1 to 1 to 126, because 127 is reserved, and from 128 it will go to class B. So in your class A, this first bit is always reserved. You can't change it. It is always set to 0. Okay, you can't change that first bit. Reason being, if you use your logic, you can answer this question. Tell me why. If you can use your logic, you can tell. Devidas, I know I've already taught you this, but except you, I want other students to answer.
So, because it starts from
Yes.
1 to 26, so that is why 0.
No,
Class A starts from 1 to 26, no, sir. So it will start.
no, not exactly.
If we change it, will be 128.
Correct. Because if I turn on this first bit, what is the value of this first bit? 2 to the power of 7. So that is 128. If I turn on the bit, then that will go to class B, right? Correct. It will go to class B. So I don't want that bit to go to class C. So that's why it is always set to 0. You can't change it. Now understand why the first bit is reserved. So likewise, if you go to class B, the first two bits are reserved, saying 1, 0. The first bit is always turned on, and the second bit is always turned off. Why? Because if I turn off the first bit, okay, if I turn it off, then it will go to class A. So I always want it to be class B. That's why I've turned on the first bit of class B. That is 128. And the second bit I've always turned off, because that is 2 to the power of 6, 64. If I add 192 plus 64, it will go to 224. Sorry, 192. 128 plus 64 is 192. That will go to class C range. So that's why the first two bits of your class B are reserved as 1 and 0. Okay, and come to class C. So it is first three bits are reserved 1100, 110. Why? Because if I add 128 plus 64, then only 192 range will come. Correct. And class C starts from 192. So I want that range to be there. That's why the first two bits are on. And the third bit is off, because if I add 32, it will go to class D. Okay. Understood or not? Understood. Okay. So now come to this. So now we'll see class A first. Okay. What is the default subnet mask of class A? It is 255.0.0.0. Okay. That is the default subnet mask of your class A. So total number of network bits is equal to 8. Okay, why 8? Because all the on parts belongs to, if the number is turned to 1, that belongs to network. If the number is belong to 0, that is host. So what are the bits here turned on? The first octet, all 8 bits are turned on. So that's why number of network bits is 8. Okay. And then first bit is fixed. First bit is fixed. That is what? 0. Okay. So total number of bits for manipulation. Total number of bits for manipulation is 8 minus 1 is equal to 7, because the first bit is fixed. Okay. So now total number of network is equal to 2 to the power of 7. That is 128. But the problem is 0 and 127 is not used. Correct. 0 and 127 is not used. So 128 minus 2 is equal to 126. So 126 networks you will get from class E. Understood? Why minus 2? Because 0 is not used and 127 is also not used. After that, total number of host is equal to, how many zeros are there? 24, not 3. 24 zeros we have, because this is in octet form. 1 0 is 8 zeros. So 24 zeros. So 2 to the power of 24. That is, I think, 1 crore 67 lakh 77 something you'll get. You tell me the value tomorrow. Okay. So 1 crore 67 lakh 77,000 and something will come. So that many IP addresses you can get from one network. From one network. How many network we have? 126 network. So 126 into 1 crore 67 lakh 77,000 networks you will get from class A. Okay. So this is the how we are going to how we got to know this many hosts, this many bit, all because of your subnet mask. So your subnet mask decides how many network and how many host. And the default subnet mask of class A is what? 255.0.0.0. That is the default subnet mask. Okay. Understood? Any doubt on this? Clear? You clear? Okay. Now you can write it down. This is called your class full subnetting. What subnetting? Class full subnetting. Tomorrow I will teach you classless subnetting. That is very important. One bit is fixed, that is reserved. You can say fixed or reserved. 0. The first is 0, right? That means your range will be like this. 1.0.0.0. Okay. 1.0.0.1. It will go till 1.255.255.255. That's it. It will go till 1.0.0.2. What is the last IP? 1.255.255.254. This is the range. Total number of hosts? 2 into 24. Why 24? Because of zeros. In your host bit, I asked you to write one point. Hosts are represented as zeros. Networks are represented as ones. Here, 255 means what? It is like this, right? So all the zeros are will be belong to host. Okay. And this is the range of class A. It will start from 1.0.0. 1 will not change. Now you can't go to 2. 2.0.0.0 will not come because that is a different network now. This is the range. You can't change the one. That is fixed. Written. And see, in this range, this IP is called network ID. The first IP of your network is network ID. So if I have to call every IP, that is 1,67,77,000 IPs there. If I have to call everyone, then I will use this IP. First IP, that is the network ID. Okay. And last IP is what? Your broadcast ID. That means if I have to send a detail to each and everyone, that 1 crore 67 lakh, if I have to send a data to everyone within the network, then I would use broadcast ID. Okay. And this is your first valid IP. First valid IP. And this is my last valid IP. So this from first valid IP to last valid IP, I can assign to computers, but not my network ID and broadcast ID. That you can't assign to a computer. Okay. So I'll show you in practicals. See, I'm going to give 1.0 1.0.0.0. Okay. And subnet mask is what? Default subnet mask. 255.0.0.0. Correct. See, I'm going to assign this IP. Let's see if it is going to take it or not. See, the combination of IP address and subnet mask is invalid. You can't assign this IP because this belongs to network part. Now I'm going to give 1.255.255.255. That is what? Broadcast ID. See, you can't give this IP. So this will not be able to assign to a system. Any IP within between the range you can say. So say for example, you can say any range. That is, I can say 1 dot, say 111 dot 112 dot 254. See, it will take. Okay, so your network ID and broadcast ID, you can't assign to a system. One is to call everyone, other one is to send message to everyone. Simple. Okay. This is your class A. Now we'll see class B. Two bits are fixed, so 16 minus 2, sorry. Write down quickly, I'll explain you. Written. So what is the default subnet mask value of class B? That is 255.255.0.0. So here 16-bit is belong to network and 16-bit belongs to host. Correct? So here you can see, so total number of bits is what? Network bits, 16. So in that 16, 2 bits are reserved in your class B. What are those bits? 1 and 0. 1, 0 is reserved in class B because if I don't reserve that, it will go to either class A or C range. So that's why those two are reserved. So that's why total bits for manipulation is 16 minus 2. That is 14. So 2 to the power of 14 is what? 16,384. So these many networks you will get from your class B. Okay. So total number of hosts is what? Again, 2 octet is left 0. So 2 to the power of 16 is 65,536. So that many hosts you will get and this many network you will get. Okay. And this is the valid range. That is 172.16 will never change. Only the next 2 octet will change because of 0.0. The on bits is for network bit that will never change. So 0.0, 0.1 till 255.255. That network is completely exhausted. Now you have to go for different network. That is what? 172.17, 18, likewise you can go. Okay. Any doubt on this class B? No. If you have any doubt, don't hesitate, ask me. Everybody is clear. Okay. Written? Write down for class C. Write down. So we are dividing this network bit, host bit, right? This is called your subnetting. This is what? Class full subnetting. We are going with default subnet mask. Correct? So if I'm having an organization, okay, I'm going to start organization. I am having 200 PCs. So which class I will go? I will go with class C because how many hosts I can get? 256. Correct? 256 I can go. So I will go with class C. If I have an organization that is more than 256, then I have to go with class B. So it has 65,000. So if I have a like very big organization and there are so many employees, more than 65,000, then I have to go with class A. See, class C I will explain you. So default subnet mask of class C is 255.255.255.0. Correct. So this 3 octet is belong to network part. Okay. So that's why 24. Network belongs to 24. Okay. And then number of bits for manipulation is 24 minus 3. Minus 3 because 3 bits are reserved in your class C. 110. So 21. So 2 to the power of 21. Tell me the value tomorrow. So that many networks you will get in your class C. But host is what? Only 8. 2 to the power of 8. Because only one octet is 0. So 256. So address will be like 192.160.10.0. So the first 3 will be reserved. You can't change the first 3 because of the subnet mask. Okay. So the fourth bit you will change from 0, 1 to 255 it is. Okay. 0 is network ID. 255 is broadcast ID. In between that are valid IPs. This is your class C. Okay. So now today we have learned what is IP address. Okay. What is the representation of IP address? We have learned decimal to binary, binary to decimal. And then we have learned what is hexadecimal. Then we have seen the classes A, B, C, D, and E. Okay. And what is multicast we have seen. And E we are not using, that is for research purpose. So we have learned class A, what is the range, what is subnet mask, network ID, host ID. Okay. Again, class B we have learned and class C we have learned. Okay. So we'll wind up here. Today's class full subnetting. I will give you the drive access now. Don't leave the meeting. So again, go watch this class once again. Okay, I know it looks understandable, but tomorrow you will forget something. Okay, so go. You have time till tomorrow afternoon. So it's what, almost 1 hour 40 minutes class. So watch it again and come back to tomorrow's class. Okay, I'll end the meeting here, but I'll give you the drive access now. So stay. Okay. Any doubt online, guys? Any doubt on today's class?
No, sir.
All
No,
right.
sir.
All right. Very good.